Welcome my friends to my YouTube channel. Now I have completed 3 chapters of thermodynamics: first law, second law and entropy. Now in today's lecture I will going to start the 4th chapter, that is Maxwell's thermodynamical relation. Now after completing thermodynamics I will start again classical mechanics. I already taught 2 chapters of classical mechanics. One is gravitation and other is central force and planetary motion. Okay, so after completing thermodynamics I will again start classical mechanics. So this is our chapter 4, Maxwell's thermodynamic relations. Okay, so we know the combined form of first and second law. That is, from first law we can easily write dq equal to du plus pdv, and from second law dq equals to tds. Okay, so if we equate them, or if we equal them, then we can write this. Okay, so what will be du? That is tds minus pdv. So this is the combined form of first and second law of thermodynamics. Now the state of any system, or you can say, or any substance, or you more generally you can say the system, can be represented by a pair of independent coordinates or variables. Okay, that describes the state of a system. So in generally the state of a system represented by this equation can be expressed in terms of 2 independent variables. Say that variables can be written as in general x and y, and this xy can be any two between this PSTV. Okay, between this PSTV xy may be any two between PSTV. Okay, any two between PSTV. Okay, so we don't know. So in general we assume that here the differential term is du, ds and dv. So we can assume they are the functions of 2 independent coordinates x and y. Okay, so we can write u as a function of x, y. Okay, so what will be my du? Since du is a perfect differential, so we can write du, that is del u del x y constant dx plus del u del y x constant dy. Similarly, we can assume s as a function of 2 independent variables, that is x, y. In general we assume that the 2 variables are x, y, and since ds is a perfect differential, we can write del s del x y dx minus, plus del s del y x constant dy. So dv, so if we assume v as a function of xy, that is dv, that is equal to del v del x y constant dx plus del v del y x constant dy. Since these 3 are the differential terms, we can express in terms of xy. Now our task is to substitute that value in the combined equation. So if we substitute these values in the combined form of first and second law, then what we get? Okay, then what we get? du, that is we can write del u del x y dx plus del u del y x constant dy, that is tds. So what will be my ds? Del s del x y, and if we rearrange it, the line becomes this. After simplifying or rearranging, this becomes this. Okay, du equal to TdS minus PdV. So substitute ds and dv, and after just rearranging we can write this minus p del v del y x. So this is dx and this is dy. So after equating both the expressions, what we can write? We can simply write del u del x y constant. This must be this term t into del s del x y minus p into del v del x y. So just give it a name, say 1, and this term can be equal to, that is del u del y x constant. Okay, this is t into this is del s del y. Okay, so p okay, so this is t into del s del y del s del y x constant. Okay, minus p into del v del y x constant. So we get these two equations by equating both sides. Okay, so now just see carefully, we have to differentiate this term. There is a del u del x, so we have to differentiate these terms in terms of y, and we have to differentiate this term with respect to x. So let's check what happens if we differentiate this expression with respect to y. So what we get? Del 2u del y del x. Differentiate equation 1 partially with respect to y and x. Oh sorry, I forgot to tell one thing, that before starting this chapter you must have to know what are perfect and imperfect differentials and the condition of perfect differential. So if you don't know it, I will tell you in the next class what are perfect and imperfect differentials. Okay, I forgot to tell it and I started, so I have to complete it. So in my next class I will tell you about what are perfect and imperfect differentials and what are the condition of perfect differential. Okay, so differentiating equation 1 partially with respect to y. So what we get? Constant t. If we partially differentiate this, it becomes del 2y del y del x, and if we differentiate partially t, so del t del y x, and this term is fixed, del s del x y, and this term if you keep p constant and do it, so that will be del 2v del y del x. Okay, and if we do it, that is del p del y x constant, and that is del v del x y constant. Okay, right. Now we have to differentiate this is okay, we have already differentiated this partially with respect to y. Now we have to differentiate equation 2 partially with respect to x. So let's do it. So I erase this thing because its work is over. Okay, so if I differentiate this expression with respect to x partially, then del 2u del x del y, this will be what? T into del 2s del x del y plus del t del x y del s del y x. This is minus p del 2v del x del y. This is del p del x y del v del y x. Okay, so this we get. Okay, so it's fine. Now we have del 2u del y del x and del 2u del x del y, both values are here, and we already told that du is a perfect differential, and if since du is a perfect differential, since du is perfect differential, the condition of perfect differential will be what? del 2u del x del y, that must be equal to del 2u del y del x. This is the condition. So I will discuss it in later. So these and these are equal. Just think, just see, this relation and this relation are equal. So if these two relations are equal and du is a perfect differential, so these two relations are equal, and on the other hand ds and dv are also perfect differential, so that means if ds is a perfect differential, then del 2s del x del y equal to del 2s del y del x. So this and this term cancels over, and if dv is a perfect differential, then del 2v del x del y equal to del 2v del y del x. So this and this term also cancels. So remaining there are two terms, and here the two terms. So we have to write it. Okay. So if we write these two terms, then what we get? Okay. So we get this. So if we write these two terms, so ultimately we get this del s del y x minus del p del x y del v del y x. This must be equal to this del t del y x del s del x y minus del p del y x and del v del x y. Okay, so let's find. So this is the general equation. Now this equation can be utilized to find out the Maxwell's fourth thermodynamical relations. Okay, fine, this is the general equation. Now we don't know there are any four possibilities. Okay, so if you write it, that is PSTV. Okay, there are six possibilities: this pair, this pair, this pair, this pair, and the diagonal pairs. There are six combinations. Okay, so at first, if you take these two, okay, so P and T, so you assume P as X and T as Y. And since they are independent, you can also assume opposite, that is you can assume P equals to Y and T equal to X, no matter. Since the variables are independent, you can also choose P equal to Y and T equal to X, no matter. So what will be my del P del X? This will be 1, and del T del Y will also be 1. And what will be del P del Y? That is 0. And what will be del T del X? This also 0. So if we substitute these values, what we get? Del T del X 0, that means this term is 0, and del P del okay, P del X del T del Y, that is del P del X equal to 1, del P del X, this term is 1, del T del Y 1, and del T del X 0, that means this term is 0, del P del Y, this term is also 0. So what we get? This is del P. Just a minute. Okay. P equal to X and del P del X 1, del T del Y 1, del P del Y, del T del X. So del T del X is 0, that means this term is 0, and del P del Y is also 0, that means this term is also 0. So what will be my del P del X? This is 1, that means minus del V del Y X. This we can write as del S del X Y, del S del X Y. So what we get? That is, what means Y? del v, y means t, del t, and x means p. This equals to minus del s, x means p, y means t. So this is one relation. Del v del t pressure constant. This is equal to minus del s del p temperature constant. Okay. Del v del t pressure constant. Del v del t pressure constant. This is equal to minus del s del p temperature constant. So this is the one relation. Okay. Now we assume Sx and Vy, that is, you can also assume S equal to y and V equal to x since the variables are independent. So what will be my del S del x and del V del y? This is equal to 1. And what will be del S del y and del V del x? This is 0. So del S del y will be 0, that means this term is 0, and del V del x 0, that means this term is 0. So these and these are remaining. So what will be my del V del y? 1, that means minus del P del x y, this equals to del T del y x. So what we get? X means S, del P del S, y means V. This is V. This equals to minus del T del V S. This is the another relation, P S V, that is P S T V. So P S V, this means minus TVS, minus TVS. Okay. So when you start horizontally and move, when you start from horizontally, negative relations are coming, minus relations are coming, but when you move vertically when you start vertically, that is positive relations are coming. That means that, see, del P del S volume constant start from this minus del V del T S constant. Okay. And del S del P temperature constant equal to minus del V del T pressure constant. Okay. So this is the second relation. Now take this pair P and S, that is P equal to X and S equal to Y. So what happened? Del P del X equal to del S del Y equal to 1, and del P del Y, this is equal to del S del X, this equals to 0. So del S del Y 1 means this term is 1, that is del T del X Y, and this term okay. So del T here del S del Y 1, that means this term is 1, and del S del X, this term is 0, and del P del Y, this is also 0, minus del P del X 1, that means minus del V del Y, this is equals to 0. Okay. So if this minus this is 0, then this equals to this. So what we get? Del T del P S, this is equal to del V del S P. Just see. Now you start from vertically, that is TPS. TPS, then go from this VSP. VSP. Okay. So this is the third relation. Okay. No problem. Now let's take the fourth pair, that is this consider and this consider. So now left this. So take T equal to X and V equal to Y. So just substitute them. So what will be my del T del X and del V del Y? This is 1. Okay. And what will be my del T del Y? Since we are doing partial differentiation, so the only variable, the differentiation will be only with respect to the variable, and differentiation for other variables will be 0. So del T del Y equal to del V del X. So this is 0. Okay. So del T del X is 1, that means this term is 1. So there remain del s del y x, and del v del y is 1, that means this term is only effective, del p del x equal to y, and del v del x 0 means this term is 0, and del t del y 0 means right hand side is 0. So this minus this equals to 0, that means this equals to this. So what will be my y? My y will be v, and what will be my x? That is t. Okay, and del p del x, that is del p del t v. Now just check it, svt. Now move in the downward direction, svt, that is ptv. Okay, so these are the Maxwell's 4 thermodynamical relations that we derive by using the concept of first and second law. So what will be the answer if anybody asks what are Maxwell's thermodynamical relations? So you have to answer that by using the first and second law of thermodynamics, and by utilizing the formulas of perfect differential, Maxwell derived a lot of relations between the thermodynamic coordinates or variables P, S, T, V, etc. These are commonly known as Maxwell's thermodynamical relation. Okay, so from the concept of first and second law of thermodynamics, and by utilizing the laws of perfect differential, Maxwell derived a lot of relations between P, S, T, V, etc. and these relations are generally known as Maxwell's thermodynamical relations. Okay, so that is the first thing. And how to remember, I tell you that when you start moving from vertical direction, that is say from this direction, just take it this, so you can start from this, del S del V temperature constant, this is equal to del P del T volume constant. And if you start from there, this, so this will be this, so del T del P S constant, this is equal to del V del S pressure constant, so it will be plus. And when you start moving horizontally, that is along this, so this will be also this. So these are negative relations, TVS equal to minus PSV. And okay, and if you do it in opposite direction, you have to do in opposite direction, that is del S del PT minus del V del TP. Okay, so if you start from vertical counting, then you always get two positive relations, and if you start moving horizontally, you get two negative relations. Okay, so this is the lecture 1 of first law of Maxwell's thermodynamical relation. Now in the second lecture of this chapter, I will going to tell you what are perfect and imperfect differentials. Okay, what are perfect and imperfect differentials, that I will discuss in my next lecture. So if you don't subscribe this, kindly subscribe this channel to get latest updated videos. And one thing must remember, that you have to listen each and every lecture of this chapter, because in this chapter I will only do mathematics, is entire mathematics, and I will do lot of mathematics in this chapter, at least 50 to 60 mathematics I will do here. Okay, so it will take a time. So this chapter is lengthy, so it will take a time. Okay, so thank you.